Okay, I'm going to give you a couple of hints. This is the in-class on day 4. And I didn't think the notes had quite enough examples on it, so I just took some of the questions right off of your in-class paper, and I put them on here so that I can show you a few more examples. Okay, so I'm going to start with number 4. See if I can get that a little bit better. Oh, that's better. And remember that we talked about how all of our problems on our notes, we're looking at the new thing that we're talking about, like area, is equal to the old one times the change. And then the change was what we put in our formulas up here. We're mostly looking at either the surface area, where we do both of them and its factor squared, or these, depending on volume, how many of the different dimensions we're changing. We also had them on the other side of our notes for area and perimeter. So the first question here, number 4, this is the first on your in-class. It says surface area, so we're talking about the surface area. So I'm going to write down our formula. Surface area new equals surface area old times change. And it says the surface area of a prism is 35 square inches if the surface area of a similar solid that has been enlarged by a factor of 7. So I want to know the new surface area. The old surface area was 35, and it was changed by a factor of 7. All the sides. So if I look at this on surface area, my change is the factor squared. So it's 35, my old surface area, times 7 squared. Put that in my calculator, and I find that my new surface area is 1715. That's all you have to do on these. The next one, number 5, is very similar to that. It's about volume. So volume new equals volume old times the change. It says a sphere has a diameter of 5 feet. If it is expanded to 2.5 times its factor, so here's my factor, what will be the change in the volume? And this is one of the things you have to be careful on these problems. You have to be careful to read what it says we're looking for. It's asking for what will the change in the volume be, not what the new volume is. So the new volume is just going to change by how much ever this is right here. Well, on spheres, we said for spheres on our notes, it changed by the factor cubed. So my factor was 2.5, so it's going to change by 2.5 cubed. So it's going to change by 15.625. I'm not putting in volume because it didn't ask me for the new volume. It asked for the change in volume. All right, my next one, number 6, says describe the effect on the area when the radius is doubled. So again, it's not asking me to find the new area, it's asking me to describe the change in the area. So if we look at area, and the radius is doubled, so we're talking about a circle, and area, if I change the radius, that's a factor squared. Doubled means times 2, a factor of 2, so area new equals area old times the change. And for a circle, it's the factor squared. So it's 2 squared. The change is 4 times bigger. Or 4 times bigger, we use the word quadrupled. Number 7, it's volume. So I'm going to write my volume formula. And the cube has a volume of this much, so that's my old volume. If the dimensions are changed by 1/4 their original size, so there's my factor, 1/4, what will be the volume of the new cube? So we're changing all the dimensions by 1/4. So volume, changing all 3 of our dimensions, that's factor cubed. So in my calculator, I put 320 times 1/4 to the third power, and that's 5. Okay, so that was number 1 through 5. The first one's on your paper. Now turn to the back page. I'm going to do number 12 for you because it's slightly different. Because on this one it asked me to find the new volume, but it didn't give me the old volume. So we're first going to have to find the old volume of this original one before we start. Well, volume of a prism is base times height, so 12 times 4 is the base, times the height of 4, and I find that the old volume is 192. So you just have to stop and use the stuff for how to find the volume to begin with before you can do the rest of it. Now I'm going to use my new part. Volume new equals volume old times the change. Here's my factor of 1/4, and I'm changing all 3 dimensions. So from my notes, if I change all 3 dimensions on volume, that's factor cubed. So my old volume we just found right there, 192. The factor is 1/4, and we said it's cubed. Type this in your calculator and you can find that it changes. The new volume will be 3. And finally, I'm also going to do number 17. Note that this is 17, not 13. This is 17. And I did this because this is an interesting one, and I even bolded this part so it was a little more obvious what it says. You're going to have to read carefully. It says, Tien bought 2 rectangular cartons. The dimensions of the smaller carton are half the larger carton. By how many times greater is the volume of the large carton compared to the volume of the small carton? So if I think about this as volume new equals volume old times the change, and I'm changing all the dimensions on volume, so that's going to be the factor cubed. And I want to know how many times bigger the big one is. So am I looking for a number like 1/2, or am I looking for a number like 4 times bigger? Well, if I want how many times bigger it is, it needs to be a number like 4 times bigger, 8 times bigger, something like that. So I don't want to put in 1/2 here because that would tell me how much smaller something is. So I want to put in here for the factor that this is 2. So what I'm really saying is I'm changing the small one by a factor of 2 to get the big one. So if I do that, it's 2 cubed, telling me that the big one is 8 times bigger.